All right, today we need to review the equation of a circle. It's probably one that you've seen before, and it has a way of sneaking up on us throughout the year in different places and even next year in calculus. Let's say that I have some circle, all right, and this coordinate right here is h, and this coordinate right here is k, which means those are the coordinates of the center of the circle, HK. All right, let's say the center of the circle has coordinates HK, and then there is a radius of the circle that we will call R. If that is the situation with any given circle, then I know that the equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. Okay? And that equation, like I said, rears its ugly head in different times, and you really need to be able to recognize, one of the big things this year is being able, and next year, is being able to recognize something as a circle. If you see something, what am I talking about? If you see something like this, x squared plus y squared equals 9, you need to be immediately thinking that that is a circle. All right? In this case, the center of the circle would be 0, 0. Okay? So you have to just, anytime you see this x squared plus a y squared, you need to be thinking, I think that might be an equation of a circle. Let's look at some examples like you're going to see tonight. Let's say you are asked to write the equation of the circle. I think your book says the standard form, but what I just showed you was the standard form. So we'll just assume we're always using standard form. All right? Let's say they give you this information. The center of the circle is 5, -3, and let's say that the radius of this particular circle is 6. So we'll start with the really easy one. What I would recommend you do is write the equation first and then plug in your numbers. This was something that I always did when I was working on my math degree. I also had a lot of physics classes in my bachelor's degree, and I learned that if I would write the formula first, it would help me learn it, all right, because you're actually saying it while you're writing it. So there's my base formula. Now I just need to plug in. This is an x coordinate of the center. This is the y coordinate. So the x coordinate goes in for h, the y coordinate goes in for k, the radius goes in for r. It's that simple. So this will become x minus 5 quantity squared plus y minus -3 quantity squared equals 6 squared. Now I'm showing every step here. I realize you probably could have went straight to the answer, which is x minus 5 quantity squared plus y plus 3 quantity squared equals 36. And there it is in standard form. Okay? Now, of course, that one's easy. But sometimes they're going to get a little bit tricky and give you some different information. What if they said the center of the circle was -1, 2, and then instead of giving you a radius, they say a solution point is 3, 4. What do they mean by a solution point? This is a point on the circle. That's what that is. Point on the circle. What was I not given this time? The radius, which means I need to find the radius. And we know from some of your years gone by, if I know 2 points, can't I find the distance between them? Using that old friend, the distance formula, distance equals the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Okay, you basically subtract the x's, square it, subtract the y, square it, add them together, take the square root. So let's see how that works out. So my x coordinates are negative 1 and 3. I'm going to work that way. So I'm going to have negative 1 minus 3 quantity squared plus 2 minus 4 quantity squared. And I would not eliminate that step, everybody. You might be pre-calculus students, but you're still, all of us are prone to make mistakes. I would show that step just so that we get the right answer. So now this is going to be the square root of negative 4, just negative 4 squared, plus negative 2 squared. So that's going to be what? 16 plus 4? Right? So this is going to be the square root of 20. And you know what? We're so used to simplifying radicals, we just want to simplify that thing right away, but I wouldn't. You know why? Because the equation of a circle squares the radius, right? So it's going to be to our advantage, just leave it this way. This is my radius. Okay? I just leave it that way for right now. So then you just go to your equation of a circle, x minus h quantity squared plus y minus k quantity squared equals r squared. My square root of 20 goes in for r, so the square root of 20 squared. And then which point up on top do I use? The center. I use this one. All right. So it's going to become, I'll just go ahead and skip that step. It'll become x plus 1 quantity squared plus y minus 2 quantity squared. And we're done except for the fact that the square root of 20 squared is 20. So your final answer, this will be a 20. Okay? Now, one other little trick they could do is they could give you this. The endpoints of a diameter of a circle. The endpoints of a diameter. And they give you 2 points. 3, negative 5, and 5, 12. Well, now I don't have anything, do I? We need to use the midpoint formula. Otherwise, we're not going to know how to find the center. So midpoint, okay, in case you forgot that one, that's why I'm here. The midpoint formula is x1. It's basically just the average of each of the coordinates. Add the two together. Oops, that should say y2. Add the two together, divide by 2. Okay, there's your midpoint formula. And that will give me the center. All right? So, using that, I have 3 plus 5 divided by 2 and negative 5 plus 12 divided by 2. So this is going to be 4. 8 divided by 2 is 4. This is going to be a 7. So that's going to be 7 halves. You can just leave it as 7 halves. We need to get used to using fractions anyway. What is this point? The center. We'll just call it C for the center. Do I have the radius? I have to figure it out, don't I? It's kind of a pain in the rear. This problem just has a lot of work to it because now don't we have to use the distance formula? Yeah, let's go ahead and get that done. And we know the distance formula. Let's just go ahead and start plugging in our numbers. 3 minus 5 quantity squared plus negative 5 minus 12 quantity squared. So that's going to be 4 plus, this is going to be negative 17, isn't it? Right? So negative 17 squared is 289. And this would be, I know, then this would be the square root of 293. Now if I did it that way, I used these 2 points. Isn't this the length of the whole diameter? So what's the radius going to be? It's going to be half of that. Square root of 293 over 2. Don't be afraid of ugly numbers, okay, of ugly answers. Sometimes they happen that way. So there's your radius, there's your center, and now we can just plug into the formula. All right? So when that happens, x minus h quantity squared plus y minus k quantity squared equals r squared. This radius is kind of ugly. It's the square root of 293 over 2, and that thing is squared. Well, when you square a square root, the square root goes away. So the top is going to be 293, but the bottom does not have a square root, so it's going to become 4. And then we just use our center, which was 4 7/2. So this will become x minus 4 quantity squared plus y minus 7/2 quantity squared. And there is our ugly equation of a circle. All right? Now, one last thing, then we're done. What if they say to find the center and radius and sketch a graph? Now let me just say these graphs do not have to be perfect. You do not have to use a compass or anything like that. Just get it close. So if they give you the equation like this, x plus 7 quantity squared plus y minus 3 quantity squared equals 1/16. Let's say that's our equation of a circle. Well, what's the center? It's not 7, 3. Remember, if this is a plus, it has to be a negative 7. So it's negative 7, 3. What is my radius? You got to think the square root of that, right? So isn't that 1/4? The radius is really small. This is a really tiny circle. So my center is over at 1, 2, 3, 4, 5, 6, 7, up 3, 1, 2, 3. There's the center of the circle, but my radius is only 1/4 of a unit, right? So in reality, you know, we'd have to break these up into fourths, right? Same thing up here, break it up into fourths before the next bigger unit. So really this thing is really small, like that, okay, because the radius is really small. And we will stop there for today.